one, we are doing the Polygon Angle Sum theorem. Is probably the largest portion of what we're going to do today. And the Polygon Angle Sum theorem, I'm going to show you how this works. And I think you're going to just be like, oh, this is great. I got this. This is easy. I have two polygons here. Can you name them? Those top two? Five-sided polygon? Pentagon. Six-sided? Hexagon. Okay, so in the pentagon and in the hexagon, I'm going to take one vertex. On this one, I'm just going to start right here. Oh, that's not a pen. This is a pen. I'm going to start at this vertex, and I am going to draw every diagonal in, okay? A diagonal here and a diagonal here. This is a five-sided figure. How many triangles did I make when I drew all the diagonals in? Three. So 5 sides, we have 3 triangles. Okay? Then we have a hexagon. Let's say I start from this vertex and I draw all the diagonals from that vertex. That would be here, that would be here, and that would be here. How many triangles did I make in that hexagon? 4 triangles. So 6 sides, and I got 4 triangles. Do you see a trend yet? What if I had a 7-sided figure? How many triangles would you expect?
5.
5 triangles. If I had an 8-sided figure, how many triangles would you expect? 6. So what's happening?
It's 2 less.
It's 2 less every time. Okay, so the number of triangles that we have is our sides minus 2, right? The number of sides, we'll do it like that. The number of sides minus 2. Okay, so we're going to talk about polygon angle sums. Okay, so they're angles. What is a sum? Addition, right? If you add up all the pieces, the sum of the angles. So take a look at this figure. You don't need to do this part. I'm going to erase this real quick for you. In this figure, I want to know the sum of all of these angles, but we've not learned any way to find the measures of the interior angles other than if we were going to measure it with a protractor, right? And we don't want to have to measure with a protractor every time. Protractors aren't as accurate as the math that goes along with them. But if I draw the diagonals in, I do know the sum of the angle measures of a triangle. What is the sum of the angles of a triangle?
60.
180, right? So that means these 3 added together will be 180 degrees. And these 3 added together will be 180 degrees, and these 3 added together will be 180 degrees. If you look at all of those angles put together, this angle, that angle, that angle, that angle, that's all the angles of our pentagon, right? I could do that on every single polygon that I could think of. All the diagonals drawn in, how many triangles did I get? How does that work out to its sum? Here's how it works out. The sum of the measures, that's an M, not a triple hump there. The sum of the measures of the interior angles, interior meaning angles on the inside, okay, of the interior angles of an n-gon, meaning however many sides a polygon has, n sides, okay, the sum is always going to be the number of sides minus 2 times 180. Okay, so if I want to know the sum of an octagon, I would do 8 minus 2 times 180. If I want to know the sum of a quadrilateral, I would do 4 minus 2 times 180. And that will always work out to the sum of the interior angles, okay? So you're going to get a lot of different names of polygons in this section. So here's what I'm going to do. You're going to try to name as many of those 3 through 12 as you can. There's 10 different ones there. Whoever names the most without looking it up, I'll give you an airhead. Okay?
9.
See if you can, just without telling me, try to name 3, 4, 5, 6, 7. I'll give you 3. What's a 3-sided polygon?
Triangle.
A triangle. Okay, so that one's a triangle. Try to name all the rest of them. See how many you can get. A triangle. Okay, let's see how you did. Your character is your judge here. I am not your judge. Grade your own. Number 4, what is a 4-sided polygon called? It is a quadrilateral. A rectangle is a type of quadrilateral, right? But quadrilateral is a 4-sided polygon. 5 is a pentagon. I gave you that one. 6, hexagon. 7 has 2 acceptable names. Did anyone get it? Septagon is one option. Anyone know the other one? Heptagon.
Yep.
Okay, so if you put heptagon or septagon, great. If you put both, I'll give you a bonus point.
Octagon.
8 is an octagon. Anyone know 9? It's a nonagon. What did you call it, Copper?
You can't even say the word the same.
Okay, how about 10 sides?
10 sides.
Like a decade, 10 years. Oops, I wrote decade instead of decagon. That's a decagon. Okay, now 11 and 12, if you figure this out, I'm really impressed.
11 gone, 12 gone.
It's not 11 gone and 12 gone, but beyond that it is. 13 is a 13 gone.
Oh, I got it.
14 is a 14 gone. 15 is a 15 gone. Anything beyond 12. Yeah.
It's called a triangle.
No, but I like it, but no. Okay, so here's where Spanish comes in handy. Who's good at Spanish? You don't even have to be good at Spanish. You just need to know how to count in Spanish. Here it is. A decagon, right? 10. 10 plus 1.
Decunagon.
Oh,
Six.
flip that up. Un
Decagon.
decagon, right? 1 plus 10 is 11. Un decagon.
Duodecacon.
Dos.
Oh, you're so close.
Decagon.
Dodecagon, right? So an undecagon and then a dodecagon. Anything beyond that, 1,000 gone, 1,000,000 gone. Good luck trying to draw one of those. But anything beyond 12, you just call the number gone. I don't know why they didn't just do that for all of them. They got to be fancy. But yes, that's the scoop. Questions on any of those? Okay, how many did you get? There's 10
I
there.
got 6.
4.
Okay, but do the math right. It's not if you got 2 number 6, you got 6, right? That's what my last class did. They were like, I got 9. I'm like, no, you didn't get 9. Count how many? 6? Anyone get more than 6?
Yep.
Did anyone get 6 other than Micah?
I did.
You got 6?
Yeah. 6.
Sean got 6? Exactly.
I spelled them wrong, but
You got more than 6?
I know.
Oopsie, my bad.
You got 7.
I got 8.
Anyone get more than 7?
Oh.
Did anyone get 7 other than Sean? I'm taking your head. 7's our winner. Okay, moving right along. So here's what you're going to do with this. By the way, this, memorize it. You're going to use it all chapter long, okay? N minus 2 times 180. So example 1 here, it says find the sum of the interior angles. And right now, words aren't a huge deal because it's the only one you've learned. But today, you're going to learn several ways to do these types of problems. Pay attention to the words. They make a huge difference. If you don't pay attention, you often use the wrong formula, and it's just bad, okay? So we're looking for a sum. In other words, we're looking for a total of all the angles. And for the interior angles, at the end of the lesson, I'm going to teach you exterior angles. So pay attention to the words. This is the sum of the interior angles. And I just told you the formula, n minus 2 times 180 is what we're doing. N represents what? The number of sides of the polygon. So if I'm finding the interior angle sum of a 15gon, I'm saying 15 minus 2 times 180, or if you want, you can just plug in 13 times 180.
Oh. Sorry.
It's all good. That becomes, and your calculator is going to be your best friend on these, by the way. You want to do a lot of calculating on these. So 13 times 180 is 2,340 degrees. Okay? So what would you do for a hexagon? 6 minus 2 times 180. And you will see, you'll get real used to, hopefully, you'll get real used to these numbers. Eventually, like when people ask me what's the sum of the interior angles of a pentagon, I'm like 540. Like you're just going to memorize it because you're going to use it a lot. So what's the sum of the interior angles of a hexagon? It is 720. And it's 720 every single time for a hexagon. So if you want to memorize, go for it. You don't need to. But I would like to see n minus 2 times 180, just in case you do something wrong. That would be helpful. Any questions on that? So that's the sum of the interior angles, okay? With these polygons, we're going to do 3 different types of polygons, and I drew pictures of each one for you. The first one is called an equilateral polygon. What does equilateral mean?
Equal.
What is equal? All the sides are equal. In an equilateral polygon, all of the sides have the same length, okay? Are all those angles the same measure? No. This one is obviously smaller than that one, right? Those are not equiangular. That is just equilateral, okay? The second one is the equiangular polygon. And equiangular means all of our angles are the same, but not necessarily all of our sides are the same. If you look, I would say these 2 appear to be the same, and then these 4 appear to be the same, but they are not all 6 the same length. Okay, so that is not equilateral, but it is equiangular. Okay, I'm going to take those markings away so you don't think that that has anything to do with it. If we take both of those things, equiangular and equilateral, and we put them together, okay? With a triangle, they had to be together, right? It had to be an equilateral triangle if it was equiangular and vice versa. With any polygon beyond a triangle, they don't have to be both. So pay attention to when they are and when they aren't. However, most of what you work with in this chapter is going to be both or neither, okay? And that's called regular. So a regular polygon is where all of your angles are congruent and all of your side lengths are congruent, okay? So when I said earlier words matter here, they really, really matter. If you see this word, regular, in a problem, that should be an immediate trigger. All of my angles are the same measure and all of my sides are the same measure, okay? Any questions on those 3? Okay, so there's a little corollary. Do you remember what a corollary is? Just an add-on. It's an add-on to a theorem we already know. So we learned this theorem, right? Polygon Angle Sum theorem says n minus 2 times 180. That's if I want the sum of the interior angles of an n-gon. If, instead, I'm finding the measure of each interior angle of a regular polygon, then I'm still going to do my n minus 2 times 180 because I still need to know the total. But if they're all the same, what can I do with that total? Let me give you a for instance. If I said 5 minus 2 times 180 is the sum of a pentagon, and then I said it's a regular pentagon, and I want one of those angles, I would go 5 minus 2 times 180 and divide by what?
The number of those.
The number of sides, by 5 in that case, right? So this is n minus 2 times 180 still, but divide by whatever that n was. Whatever number of sides you had, that's what you're going to divide by. Okay, so like I said, words matter. This question is saying what is the measure of one interior angle of a regular octagon. Every one of those words is very important here.
8 sides.
It has 8 sides. That's what you should be picking up from octagon. Regular meaning all the angles are the same, right? We only want one of them, and we haven't learned the exterior angles yet, but you're going to learn exterior. So we want the interior angles. So what is the measure of one interior angle of a regular octagon? What do you do?
138. Oh wait, that's wrong.
You just plug what into that formula? 8, right? It's an octagon, so 8 minus 2 times 180 would give me the total. That's the sum, right? I just want 1, and they're all going to be the same because it's regular, so I can divide that number by 8. So plug into your calculator 8 minus 2 times 180, hit enter, that's your sum. Now divide that by 8, and I get, so 1080 divided by 8, if you will, is 135 degrees. So one interior angle of a regular octagon would be 135. Is this making sense? You get what I'm talking about here? Okay. If it's not, tell me. I can give you more examples. Okay. Example 3. Now this one has far less information. All it says is find the measure of angle Y. Is that a regular polygon?
No.
No. How do you know it's not regular? There are different side lengths and there are different angle measures, right? Okay, so think through what you've learned thus far. Polygon Angle Sum theorem, how to find the measure of 1 if it's regular. What would you do to figure out Y? How many degrees is Y?
138.
No.
It doesn't
Did
match
you
up.
take 138 and then we minus 90? Or no?
Nope. Can anyone tell me the sum of the interior angles of this figure?
138 plus the time for 3 times 90.
40?
Is part of it 540. This is a pentagon, right? So to find the sum, I would go 5 minus 2 times 180. So the sum of all of them is 540, right? This is the sum of all of the angles. How many angles are you missing? 1. So now it becomes a very simple algebra problem. Y plus 3 90s plus that 138 should equal what? 540, right? If I add all of these angles together, it should equal my sum of 540. So all you do is calculate this. That is, what does that come out to? 408. Okay, so Y plus 408 equals 540, and take away that 408. So I get Y is 132 degrees. Okay, questions on that? Do you see how there's a lot of different little things that you can do? So you really got to figure out what each individual thing does here. If you want the sum of the interior angles, n minus 2 times 180. If you want one interior angle, close only counts in horseshoes and hand grenades. Have we been over that?
I haven't heard that one before.
No?
Isn't it almost? I thought it was almost. That's the
Almost?
Wait, say it
almost
again?
like
Close. No. Either way.
What's hamburger?
If I throw a hand grenade, I just got to get close and it's going to
Oh, and
do
it'll
its job, right?
okay.
Yeah.
Gotcha.
Okay. So that's interior angles. Everything we've done so far is angles on the inside of the figure. This is angles on the outside of the figure. And you've talked about exterior angles before, so you should know what an exterior angle is. How many exterior angles do you see in this picture?
3.
3. This is exterior. This is exterior. This is exterior, right? Those are exterior angles. Now, a couple of things I want you to notice about the exterior angles here. Let's say I knew that, I'm going to take those letters away. Let's say this is 100 degrees, this is 30 degrees, and this is 50 degrees. Does that make sense for a triangle? Yeah, they add up to 180, right? Okay, so if that adds up to 180, can you tell me the measure of this exterior?
80.
80, why?
Because linear.
They're a linear pair, right? They make a straight line. So this would have to be 80 degrees. What is this y angle?
130.
That would be 130 to add up to 180 because this is a linear pair. And then the last one would be 150 to add up to 180. Okay, so now look at these angles. We have 150, 80, and 130. 150, 80, and 130 add up to what? 360. Okay, here's what I want you to think about. If I took the 3 vertices of this triangle and I shrunk that triangle down until all 3 of those vertices met in one point,
Just make a circle.
you'd make a circle, right?
Isn't that true with anything though?
That happens with every polygon. So what does that mean about every polygon's exterior angles?
They're gonna
Equal one.
They will
360.
always add up to 360. Isn't that beautiful? So beautiful. I love it. So here's what it says. The Polygon Exterior Angle Sum theorem says the sum of the measures of the exterior angles of a polygon, that's if we have one exterior angle at each vertex, okay? One per vertex, is always going to be 360. So notice, the interiors do not have a set total. Those change all the time. 5 minus 2 times 180 is 540. 6 minus 2 times 180 is 1080. That number changes. If we're talking about the exteriors for a pentagon, for a hexagon, for an octagon, they will always add up to 360, always, okay? So if you look at this picture, it says, what is the measure of angle 1 in the regular octagon? What is a regular octagon?
8 sides.
All sides, all angles are congruent. Okay, so if I were to draw every exterior in right now, how many exterior angles do I have?
Well, 9, 8.
There's 8, right? 1, 2, 3, 4, 5, 6, 7, and 8. If this is a regular octagon, every one of the interior angles is congruent. What does that mean about the exteriors then? They're also congruent. If they're gonna make a linear pair, if they're gonna add up to 180 with the angle next to it, they must all be the same. So that means all of these are the same, right? So if I want the measure of one exterior, and I know they all add up to what?
360.
360. If they're gonna add up to 360, what can I do with 360 to figure out what one of those angles? You guys are so smart. Divide by 8, right? 360 divided by the number of sides is gonna give you 45 degrees. Anyone see a different way that you could have figured that out?
45. I would have just done 3. Oh, we did that.
What if you forget that exterior angles add up to 360? What could you do?
Well, you could take the interior and figure out the exterior. and
You
add
could
all of
solve for the interior, right? If I wanted to do the interior ones, maybe don't write this down unless you can keep this straight. Interior would be 8 minus 2 times 180 divided by 8 will give us 1 interior angle. That's the 135, right? So the interiors are 135. So then our exteriors have to be 180 minus 135, and wouldn't you know, that's 45, okay? So the beauty of this chapter is there's multiple ways to get there. You can use the interiors, you can use the exteriors. You can't use the exteriors as often because exteriors are a lot more convenient when it's regular, but you have options, okay? So pay attention to that. Hopefully, it comes very quickly and easy for you. Any questions?
Why do I
Something
read
funny.